so lesson number 7 is one of 3 lessons that looks at the graph of a polynomial function. So if we look at a review of things that we learned last year and this year, the blanks of a function, the blanks of the graph of the function, and the blanks of the corresponding equation y equals 0 are the blank numbers. So how do we fill in all of these blanks? Which goes where? The zeros deal with the function. What deals with the graph of the function? X-intercepts. And what of the corresponding equation? The roots. And what about these 3 things? The roots, the x-intercepts, and the zeros? They're the same numbers. Okay? There is a theorem called the unique factorization theorem. Basically, in a nutshell, what it says is I can factor polynomial functions. And when I factor a polynomial function, I'm going to get a unique set of factors. So I'm not going to get the same set of factors for 2 different polynomials. They're each going to have their own. So every polynomial function can be written as a product of its factors and a leading coefficient. And every polynomial function has the same number of factors as its degree. So a 3rd degree polynomial has 3 factors. They could be the same factor. It could be x plus 1 times x plus 1 times x plus 1. But it has 3, it can't actually in that case, but it has 3 factors. So if it's a 4th degree polynomial function, it has to have 4 factors. Okay, it's an important thing to know. In this lesson, we're only going to look at leading coefficients that have a 1 or a negative 1. So if I look at class example number 1, I have a cubic function, x cubed minus 2x squared minus 5x plus 6. The polynomial has integral zeros, which means that they're integers. There's no rational numbers here. So what are the zeros of this polynomial? And how do I know those are the zeros of the polynomial? Because they were the x-intercepts of the graph. If they're the x-intercepts of the graph, they are the zeros of the polynomial, which means they would also be the roots of the equation. Now if I take those zeros and write them as factors, what would I get for factors? So those are my 3 factors, which means in factored form, p of x would equal x plus 2 times x minus 1 times x minus 3. So if I took out my calculator, if I typed this in, so y equals, if I clear that, x to the power of 3 minus 2x squared minus 5x plus 6, and then if I put in my 3 factors, x minus 2 times x, or sorry, that should be x plus 2. X plus 2 times x minus 1 times x minus 3. And then just scrolled over to, oh, sorry. Fix that. If I scrolled over on the y2 and I made this line thicker, when I go to graph them, I could see what the 2 graphs look like. So then when I press graph, there's the first equation being graphed, and there's the second equation being graphed, so I can see that the 2 equations overlap. So that just verifies that they are the same equation. Rachel, do you have a question?
I just don't know what I did wrong.
Did you use a minus or a negative? Okay, second example. Use a graphing calculator to sketch the graph of the polynomial function p of x equals negative x squared plus negative x cubed plus 4x squared plus 7x minus 10. So I'm going to give you a couple of minutes. I want you to graph this and state the intercepts and then try to write this in factored form. Okay, so if I graph this, and if I sketch the graph, I get this graph that kind of looks like this. What are the x-intercepts?
-2, 1, and 5.
So -2, 1, and 5. So if I was to put these as factors, what would my factors be?
X + 2, x - 1, and x - 5.
Okay. If I put these in, so you already have this in for y1. If I put this in for y2, do I get the same graph? Do that for me. So negative x cubed 4x squared plus 7x minus 10. X plus 2, x minus 1. So do I get the same graph? No, I don't. Why? What's the first term of my graph?
Because it's a negative.
How do I get this negative x cubed in there?
If you reflect it. What if you reflect it?
What if I put a -1 in front? So try that with your calculator. If I put a -1 in front of that x squared, or sorry, in front of that x plus 2, so I go second, insert, -1, and now graph it. Do I get the same graph now? Yes. So because that leading coefficient was -1, it's like I factored out a -1 before I did the zeros. Okay. The left arm of this graph is doing what? Rising. The right arm is falling. The degree of the polynomial is? And the leading coefficient is negative. Okay. Question number 3 for this assignment asks a lot of these. And you're going to use the results from question 1 and 2. But what I did is I picked certain questions from 1 and 2 so that you wouldn't have to do all of them to make it a little bit faster for you to do this assignment. So from question number 1, it's C, F, G, and I. Question number 2 is A, B, and E. And then you can use those results to answer question number 3. This gives us some very important characteristics so that in the future, if I tell you these are the zeros and this is the degree of the polynomial, can you sketch me what the graph kind of looks like? You will be, and if I told you what the leading coefficient was, if it was positive or negative. So that's the relationships and the patterns that you're looking for.